Good afternoon, everyone. So thank you for joining this session on threat modeling for regulated software. I know this is the last session of this great 3 days, so thank you, everyone, for your attention for this last session. All right, so a bit about there. So I've been working on IoT development for many years, and about 5 years ago, I moved into the pharma industry. And this move requires a different perspective in terms about software security, because we add the compliance perspective into it. And in the last few years, different agencies have been trying to catch up with the new technologies and emitted a few publications that force the companies and organizations to update their framework heavily. Right, so in this session, we'll explore all the consideration of integrating software development with security compliance practices. All right, so maybe before getting started, if I can get a quick poll there of how many in the room done security risk management. Okay, 1, 2. All right, a few members. Thank you, everyone. All right. All right, so quickly on the agenda, so we'll start from a high-level overview first, and then talk a bit about the process, the team, before getting in the more technical aspect and techniques. All right, let's get started on the overview. All right, so why doing threat modeling? So of course, it is about making a secure product and software, but from a business perspective, it's about cost optimization. But we want to limit the number of security incidents, which later cost to the organization, and nobody wants to make the headlines in the news. Second element to reduce cost is about shifting the effort left. We're all familiar with that. The bug and security issues cost much more to be resolved later on in the software life cycle. So this chart is from the NIST already many years ago. It's still valid today. And lastly, we want to focus our effort on what is really important, right? Because we have limited resources, so we want to spend them wisely. All right, so what we see here is the representation of cost benefit of quality and security. On the far left there, right, we can see software with ad hoc controls will have lesser value because maybe we'll have less traction in the market, and also they will cost more because of the security incidents that will impact later. And then on the far right there, we have exhaustive controls, which cost, of course, a lot to implement. So the goal of threat modeling is to find the optimal point where we invest the right amount in the security measures. All right, so let's talk a little bit about regulated software landscape. So regulation means there is an authority which emits requirements for a specific industry, and there is multiple of them: pharma, industrial, finance, and so on. And since those are jurisdiction specific, this creates a very segmented matrix of guidance and publication, which in turn creates a scattered and inconsistency on the terminology, on the requirements, and so on. But overall, they all have the same elements that they define what needs to be done, but they don't talk too much about how you are supposed to do it. All right, and even within the same space, there is multiple level of requirements. So typically the case of the US healthcare, you have the medical device that contain software inside. On this chart is on the far right. In the middle there we see the software as medical device, and on the left you have supportive software for the production and testing of medical device. And all those have different levels of requirements. And within those categories, they will have subcategories with different level of requirements based on their risk. So this is kind of the first challenge for every team building a product in this space, is to identify in which categories and which type of requirements is needed for the product. Okay, I collected here a few samples of them, not to go into details, but despite the number, when it comes to the actual the techniques to implement, there is a lot of overlap. And it's not only about the regulated software, many of those actually technical elements are from the general industry best practices. Right, so which leads to our second topic. So what are the common elements that emerge from all those sources? And then how to integrate them together. So while this presentation is more focused on the pharma space, primarily because the FDA have some very opinionated guidance, so it's easy to reference. But good software security is absolutely cross-industry and reusable. All right, first step, right, to create a risk team. So risk management is not an individual task. You cannot do it alone. You need to create a cross-functional team. Why? Is because you need to provide different perspective and avoid blind spot in your risk analysis. So you will need typically the technical perspective, some perspective from the customer, some perspective from a security specialist, IT, and from also, of course, quality and compliance as well. All right, so you will put that together and create a super experts team to power our risk coverage. But they still need to be trained. We need to provide the right materials for them about the product, requirements, architecture, charter, and so on. And also to coach them, right? In some industry, there's specific risk standard that needs to be trained on, typically ISO 14971 in healthcare. Right, and this is one of the first challenge. You have to have access to this panel of experts in your organization. And not only you need to have access of them, they will need to dedicate substantial time to your project. All right, we are ready for risk management, so let's look at the main activities. So there's two main phases there. So first, during the design phase, we will go through the risk discovery and ask to the team the question, what are we working on, in order to clarify any assumption, the scope, and the objective. Then we will move into the identification and ask the question, what can go wrong, in order to get a list of risks and a list of threats. And then with this list, we'll perform assessment of those threats and ask the question, what are the odds and what is the impact of those risks? And then finally, with that, we will define what mitigation need to be taken to control those risks, and we'll ask the typical question, what to do about it. Right, and there is the end of the first phase. Then your controls get into development cycle, and once this is all performed by the development team, the team will gather again for the review phase. And then the team will ask the question, did we do a good job at it? They will check about the testing activity in order to adjust the residual risk. And then package that for reporting and document and communicate the results. Right, so your product might be quite complex, right, with a lot of features. So you will need to make sure that you make your risk management meeting very efficient. So there's different techniques there of brainstorming session to apply. I will not get into details, but it's quite important because you want to use the time of your expert efficiently. Otherwise, you will use the engagement for your project. All right, let's do a quick example. So let's see a minimalistic example of a web server with a database. And usually we capture those elements into a table that usually called a failure mode and effect analysis table that we see there. So we'll try to brainstorm a few risks quickly. So I don't know if anyone can tell me an example of risk for our web server. Anyone have an idea? Typical risk for web server, anyone? All right, I'll get for it. So cross-site scripting, actually I heard this one at least 5 or more times in the last 2 days. Very typical. And then the risk team will go through the activity mentioned earlier and provide them a risk rating. Okay, same for the database. What is the, anyone can propose typical database risk? SQL injection, right, thank you. All right, SQL injection, same process. Right, then those controls are defined by the team and provided to the development. So once the development is completed, we review the testing success, and the team will agree on reducing the risk or not based on the result. All right, we are almost good, but now there's one more important guidance. So in regulated space, we need to follow the good documentation practices. Why? It's to be able to provide evidence in the case we have an audit from the regulatory agency. So what does that mean? That means that you need to have in place a governance structure to define all your processes, and then to ensure accountability on all your documents with review, approval, and digital signatures. And finally, you need to trace those documents through any changes, so you'll need to maintain revision history on all those documents. So this is not the most exciting part, but it's an absolute must for the regulated space. All right, so risk is not a one-time thing. So you will have to keep it updated. And there's multiple reasons for that. So typically, at the first time, you might not have all the information at hand. So you might need to iterate in order to reach a consensus. And then it's a loop, right? So you get requirements that feed your design. Your design will be helpful to do your risk management activity. Out of that, you will define new controls. Your controls will feed the requirements, which in turn will update your design, and so on. So you will need to make sure that change of the design because of your control will not create new risk. So it's an iterative process. Then, of course, once you have new feature, you will need to do change control and redo your risk assessment. And even you don't change anything, right? The risk landscape keep evolving, right? So you'll have to do risk reevaluation on a regular interval. All right, so one version is complete. It's great. And while in regulated space, traditionally use a waterfall development model, innovation never sleeps, and more we want to use agile development practices in order to have faster cycles. So there's several ways we can do that. One option is to create a validated batch and have 2 layers of life cycle, one for the development team, which will design, develop, and test the feature one by one using agile methodology, sprint by sprint, and another layer of quality validation release, which will create all the formal activities, including risk management and threat modeling. Another approach is to do all this circle as part of the agile development and to perform risk management and threat modeling for each feature as part of the agile process. So this has the benefits to have much more agile deliveries, and every few weeks you can maintain a validated, regulated software. However, the challenge is this happens then every week. So every week you need to gather with your risk management team and reevaluate your risk and so on. So this requires a highly optimized process. All right, today we focus on security, right? But this is not the only source of risk. And typically in healthcare, we have safety risk, which plays a major role. And those are 2 distinct processes, but they connect with each other. So typically, those 2 teams will be composed mostly by the same people, same experts. And then as both of them feed back their controls into the requirement that impact the design, you will have to re-perform the risk analysis every time there's a change from one control, from the, for instance, safety controls or security controls. And lastly, those controls might conflict with each other. Right? This is the typical example of fail-safe versus fail-secure. And typically in the healthcare space, you will want to prioritize, of course, safety of your user over security, but it depends on your product. All right, so what is the lesson learned so far? Right. My take is you need to make very good friends with your risk management team because you will see them a lot before the end of your project. Okay, so now we have a complete list, we documented it properly, and so on, and we approach our organization, regulatory affairs specialists, in order to handle it and file it to the regulatory agencies. However, he might get back to you and ask again for your help, right? Because he will have to defend to the regulatory agency that you covered all the security risk. Right, so this is a tough question. How are we supposed to justify that we covered all the risk in your software? Right, your team might become super demotivated. However, we'll see how we can help them. Right, so the goal of threat modeling now shifts. Right, previously we wanted to optimize cost. Now we want to be able to be in a position where we can defend that we've done everything we could to provide a secure product. And with this shift, now we need to be even more careful about the gap there of the cost of quality and security. So we need to make sure that this process is efficient. All right, so we're reaching half there. Now to look at the more technical elements. So brainstorming risk is not enough, right? We need to support the team with a systematic, repeatable, and defensible process. Okay, thankfully, they have quite some resource out there, plenty of input. However, most of them will not go far enough for the use case in regulated software. But still very good resource to start. All right, before we dive, as mentioned, there's various terminology on across different publications. So I will just clarify very quickly for the end of this presentation. So the asset is the valuable item that we try to protect, right? Typically, it's your user data. And those assets are handled by a component. In the context of software development, this is your software. Your software will eventually have some bugs or design issues, right? What we call flaws. It won't be perfect. So you will try through the risk activity to find those weaknesses and resolve them with controls, right? So like that, you have resolved the weakness and your software will not have them. But you might miss some of them if you don't do the right risk identification. Right, and those weaknesses, once you move your software into production, they will transform into potential vulnerabilities. So of course, you will try to cover those vulnerabilities later, right, by adding system-level controls to supplement your security. However, that might still left a gap in between that could be exploited. Right, and once you have a gap, it's just a matter of time until a malicious actor will find it and will try to find a vector in order to exploit the vulnerability and create damage to your asset. And which leads to the definition of risk, right? The potential that a threat can cause damage. All right. So let's start from the discovery, right? How we can analyze our attack surface. So the typical way to do that and widely documented is the data flow diagram. It's discussed in many guidance. So I will not get into details, but just a few comments there. Those components have between them data flows here. It's important to understand the direction of those data flows. It's not necessarily about which way the data is going, but it's more important to understand which components open the connection, because this will help to identify the behavior of the components. And then the second element I want to highlight is the trust boundary, right? This box around there. So usually the trust boundary means the component within are trusting each other. They don't need to perform authentication or some advanced control. But nowadays, we want to try to optimize that and go toward a zero trust design, for your software and system. So ideally, we always want to enable to authenticate and validate the other components and not rely on trust zone. All right, and then a few last notes from a regulated standpoint. Those diagrams need to be print safe. That means you cannot use any colors. Those are going to be printed on actual paper. So there's no need of any fancy tooling to have some fancy diagram and so on, right? Because at the end, it needs to be very readable and visible on simple paper. Also, one element to keep in mind is it's very easy to miss some element there, right? Typically, your web application might have some temporary cache folder or things like that you will not see during the initial design. So this is something to highlight the importance of iterating on the risk management to identify those elements later. Then there's other type of visualization that can be helpful for threat modeling. Some of them are even mandated by the FDA. I will not go through them in details, but including how you're going to manage your software later, how you're going to do backup, how you're going to update them, and so on. All right, so the DFD diagram is really important for human comprehension. However, the goal there in our threat modeling activity is to get to build a list of components and their attributes so we can analyze where is the attack point. Right, so in this table there, I briefly put that for different components there. So their type, DFD type, and understand the criticality of those components. And this is mapped with the asset that they are handling. Typically their PII, which is personal information, to define the criticality of the asset. Then it's important to understand the technology because that will help you later to scope the potential threats. And finally, the behavior, right? Is it calling to the outside? Is it accepting connection? Does it have a user interface built in? Does it persist files on the file system and so on? All right, so, but actually, I suggest to reverse the flow, not to start by the diagram, but to start by building the list. And this is where it's really interesting to use a machine-friendly format like YAML there, where you can define much more details about your components, their behavior, their technology, and so on, than you can do in a diagram. This will also help you to keep independent from specific design. Right? You could have different agencies that ask you different type of diagram, and you want to make sure you can maintain it. And one personal experience there is I saw in the last several years one piece of software that had 4 or 5 different DFD diagrams made just because there's different preference, there's new tools coming, so every time we create a new diagram. But then that makes it much harder to maintain. That can create confusion of which one is the latest version and so on. So it's much easier if we can automate the content of those lists through the CI/CD pipeline. There's a few tools there that can do that. But currently, there's no standard for defining it, and I hope that eventually the industry will come with a standard to define components. All right, very quickly about Stride. Everybody probably knows about Stride. It's very friendly because it's widely popular. It maps to the CIA triad. It also maps to the DFD element, so you can very easily apply it to your components. However, it has a few limitations. First, it's not exhaustive, right? You can see there's 6 categories there. It doesn't mean that this covers all the potential threats. Then one category might have multiple threats. It's not a one-to-one mapping. And finally, the key element there for process, which is your software, right? It's all over the board. So it will not actually tell you much about your threat coverage, right? But it's still a good start, but it's not going to be enough. All right. So let's move into the risk identification, right? To produce a complete and defendable list of risks. So there's multiple perspectives to approach this task. You can look at it from the asset perspective, or from the threat actors, or from vulnerability, or from a control perspective. From a software perspective, you will usually, it's highly documented to look at it from a vulnerability perspective, and there's a few guidance there that discuss about that. And a reminder there, right, again, vulnerability there is similar as weakness, it's just in a different stage of the software lifecycle, right? The weakness will be at the software development stage, and they will turn into vulnerability later when they are into production. All right. Now we need to build this defensible list of security risks. And the key element there to help us is the industry knowledge base. Typically the one from the MITRE, OWASP, NIST, and so on, that enables to provide a market-vetted list of threats, especially those that are built from real-life observation, like the CVEs, and that's mostly the case of the MITRE ones, the MITRE CWE or the MITRE attack. And those lists have a large number of items, so you will need to be able to scope which one are applicable to your application. Right, so making this section is quite important, and that's why you need to have the previous list of previous list that detail the behavior and the characteristic and attributes of your components. So you can justify the selection of your items through those knowledge base lists. Right, and not all those lists have the same level of information. Some are more easy also to consume from a machine-readable way that will enable to do the selection automatically. And this is something interesting, right? Because it's not a one-time effort. Every time there's new version of CWE, which is published by the MITRE, you will want to pull that and redo your risk analysis. And if you need to do it manually, this is obviously a tremendous effort. Oh, lastly, right, linkage. You can see on the far right, those knowledge base in some case link with each other. And this is also a very important element in order to build a complete threat profile. So you can build together those pieces between the weakness, the potential attack vectors, the type of assets, and the controls to mitigate them. And further, how you can test those controls. Okay. Regardless of the order, right, the goal is to build a full risk profile. So the point of the risk profile is later to be able to justify the input into your risk assessment. So here we capture that in a risk table for the example that we saw earlier, the cross-site scripting and the SQL injection, referencing the CWE entry, and then following the linkage in the guidance, the threat CAPEC, and finally list of controls from the OWASP ASVS. And here we notice that compared to our manual brainstorming session from earlier, where a single control was identified for the XSS attack, there we have actually a numerous number of controls that are recommended to cover those. All right, so now we have a solid base. It doesn't mean that there's no need of a human risk management, right? So, but this will provide a base, and then your team can then focus on risk and elements which are specific for your use case. All right, so now that we have a list of risks, we'll have to assess them and integrate the control while keeping it all sustainable. All right, you probably all know the famous risk formula. So the risk is equal to the probability time impact. There's a few methods available to perform this activity. So the first one documented is usually the quantitative approach, which leverage numerical inputs from statistical data. Right, so this makes it very easy to justify because your numbers come from statistical input that you can justify. It also helps to justify the cost of your controls because you will know how much your controls are saving for the organization. In most publications, quantitative risk always come with the same example. So I don't know if anyone went through that. Anyone knows the common quantitative risk example? No. All right, I will briefly go there. Right? It's always the example of the tornado where you have a probability of your tornado to hit your data center, let's say 1 time every 50 years, and you can calculate the cost of rebuilding your data center, which will give you an estimated yearly cost for this risk. In this case, 20,000 per year. Right, so it sounds very easy, it's defendable, so it's great. But the challenge is when you build a software, you usually don't have statistical number to defend the probability that your risk will happen. And it will be also very hard to justify the cost that will come from an attack. Right, so we need to look at another way to measure our risk. And another way here is the one we use in the early naive example, using a qualitative approach, which is based on fixed class, right? You have class for probability, class for impact, and you use a matrix to then figure out which risk score to give to your different risks. So it's also very easy to implement, and it's also flexible because you can build a matrix according to your need. However, the challenge is all those elements need justification, right? You need first to justify the class that you are constructing. Then you need to justify your matrix. And lastly, every time you have a risk, you need to justify why you give it a certain or certain class. So it will create actually a lot of work for your team. All right, which leads to other methods that mix class and numerical model together. And before I go further, there's 2 considerations to remember when selecting an assessment method. It needs to fit with the acceptance criteria, how you're going to define what is enough for your use case or not, so that, for instance, in this case of the qualitative, is that going to be high, is going to be medium, so you'll have also to justify how does that fit together. And you will also have to consider how to update your risk measurement based on the controls, right? All right, so there's multiple methods available out there. Typically, what they will do is they will divide those 2 probability and impact input into sub-parameters. Many security publications will add a threat vector into it, and then more advanced methods will break down further every entry into sub-entries and up to very detailed trees. So it sounds great, but the challenge with that is is that the greater number of input you have, the greater number of elements you have to justify. Right? It's not because you have more input that you need to justify it less. So it's not necessarily helping you to have a very complex entry model. Right, and also threat information might not be available when you design your software. Right, so you also have to choose a model that works with the information that you have when you perform your risk analysis. So for that, there's a few methods that send out. And those are that provide a defined guidance and input entries for each of the input parameters. And this is the case of the OWASP risk rating, which is more focusing on the system, and the CVSS. Right, so CVSS has a bit of controversy because it is originally a vulnerability scoring. So there's some who argues that it is not fit for risk assessment. However, the FDA clearly stands there that focusing on vulnerability is the way to go, and explicit qualify the CVSS also later. So, and moreover, CVSS is widely discussed, widely supported. There's plethora of resource out there. So it's making the most easier method to justify, at least for software risk assessment. Right, and taking the example of our cross-site scripting earlier, right, so we see those are the inputs from risk management. Without getting on the details, but we need to map those input parameters into the information that we collected earlier during our risk profile. Right, so from the component information, from the attack vector, from the weakness element, and so on, to be able to justify all of those inputs. Right, and sometimes it might not be enough. Maybe some of those information still have ambiguity about how to select a parameter, and this is where it's handy to build an attack tree. Well, I'll not get too much into details there, but basically the attack tree will enable to understand the sequence of events during an attack, the dependencies, and the time sequence. So it's mainly used here to justify the input into your risk assessment, but it also can be used later for executing penetration testing. There again, leverage the knowledge base, typically from the MITRE. On the left, this is more for the system level using the MITRE attack, and on the right, using CAPEC and CWE. All right, so now we have a risk score. We added that into our risk table for this example earlier. Get this defined risk. Now it's time to create the control, right? So we had those controls defined from the security guidance and the knowledge base. For each of those controls, we'll create a requirement ID that will fit our development. So, and once is in part of your development cycle, the same like any other requirements, those are going to be verified during the testing phase. But this is not going to be enough, right? Because the goal is not to verify that you implement your control properly. The goal is to validate that you actually reduce your risk. So this comes the validation testing. and there again, to look at what the guidance and the knowledge base are telling you how you can detect a risk in your software. So typically there's multiple tools, SAS, DAS, fuzzing, load testing, and so on that you can put in place. But you need to be sure that those tools can actually detect the vulnerability or the weakness that you are looking at. So this is not necessarily easy to find the right tooling, and even some toolings pretend they can find it. You have to be able to justify it to the regulation. Right, and the FDA states that the testing effort should be proportional to the level of risk, right? So if you have a very high risk threat, you will want to perform more testing to make sure that, okay, this vulnerability or weakness is not present in your system. And this is where you can then perform penetration testing using your attack tree in order to test manually, okay, is this issue present or not in your system. Right, finally, some of the controls might not be inside your software. Maybe those will need to come around it in your environment. So you still need to document those, and ideally to have those as part of your configuration baseline, because if you can help your user to automatically be secure by default, this is the best. Okay, so not that our tests are complete. We'll need to reevaluate the risk and calculate the residual risk. So the challenge there is for CVSS, there's no way, there's no parameters for natively integrating the mitigation into the risk score. So you have to come up with your own formula to address it. And there's no widely accepted approach yet. So in this example, we just use an exploratory ID to do so. So the idea is to calculate a confidence score that this weakness is not in your software. So to calculate this score, one potential way is to benchmark the controls that you implemented against all the benchmark proposed by the knowledge base, and performing the same for the testing activities. So in our example, right, if we have the guidance recommending 8 controls, and if your team implemented 6 of them, that will give you a 75% confidence that you covered those elements. And same for the testing. If we have 3 recommended controls, we do 3 of them, that will give us a good confidence that you cover the vulnerability. But it's important to note that if any of those tests fails, it actually means your vulnerability is there. So you cannot adjust your risk score at all. The original risk score have to remain. All right, so we are all done there. So now we still need to feed that back in our good documentation practices, starting by documenting all this process that we just go through, how we define our risk identification, listing, assessment, and so on, into a risk management plan that define all those activities together and how those activity maps with each other, and leads eventually to the risk report, which summarize all the activity and all the results for your software. Right, and not to forget about the package for your user, right? The documentation, security views, and the secure configuration baseline to make sure that they are prepared to set up a secure environment. All right, so we talk about software security. Of course, we need to be aware this is only one layer in the security stack. So usually in organization, there's different teams responsible for different risk layer. You will have a different team for the secure software development lifecycle, for the system security risk, or for the organization layer, where you will be more focusing on business continuity and things like that. But it's important that those layers connect with each other, so you need to reach to the other teams to make sure that there's no gap between the security risk effort. All right, so to summarize a bit there, right, the goal is to power your team with the right tooling, right, in order to have confidence that they covered all the security elements in their software, right? So to make it repeatable and efficient, to base on the most commonly documented tooling like DFD and CVSS, to use the knowledge base, really important to be able to justify the coverage. Make sure to automate, but ultimately it needs to be defensible, and at the end, who is accountable is the human, it's not the tooling. And also apply to AI. We talk a lot about AI, but at the end, in regulated space, the human is accountable. Right, and there's no one-fits-all approach, right? Every use case needs to have its own customized elements.